What is up, math superstars? This is Mr. Peterson bringing to you objective number 16. So in this objective, you will be able to compare and contrast dependent and independent events. And you'll also be able to determine the probabilities for dependent and independent events. So here we go. You have this word probability. This is when you have, and the underline is, more than one event occurring. The events either have an effect on each other or they do not. And so that's where we get independent and dependent events occur. So now we're going to talk about dependent events. With dependent events, these are events that will affect each other. These will have a statement that says or implies, and this is the key, without replacements here. So you're inside of the word problem, it'll either say without replacing, without replacement, or it'll give some phrase that implies that you do not or cannot put it back with the rest of the items. So now we have independent events. These are events that will not affect each other. These will have a statement that says or implies with replacement. So these are events that they have no, you can have one event happen and the second event happen and there's no overlap that goes on. You might actually see the phrase with replacing or with replacement. A good example of this is that if you roll some dice and then you have a spinner or flip a coin, these events have no effect on each other. We classify that as an independent event. So what's going to happen is you now are going to be responsible for classifying the event as a dependent event or an independent event. They cannot be both. So what operation do we use when determining probability? We use, multiplication. So when you're multiplying, you're either going to multiply your fractions together to get the probability. So here we have an example. Here it says, I have a bag of 4 red marbles and 3 green marbles. So we go ahead and already underline key phrases, or 4 red marbles and our 3 green marbles. What's the probability that I'll pull out a red marble, then replace it, and then pull a green marble? So the key phrase here is replace it. So right now, what type of problem is this? Is this an independent probability or dependent probability? So if this is with replacement, this is an independent event. So now let's talk about what the actual probability is. So here in my example here, so we have to figure out the probability of pulling a red marble first. So we write this in math, we write this the letter P, and then we put in parentheses the word red. So it tells us the probability of pulling a red marble. So our numerator tells us how many red marbles there are. And our denominator is the total number of marbles. So this is the total number of marbles. So now we're done our first part. So since I am replacing the marble, we notice that the probability of the green marble, so there's 3 green marbles. You notice 7 right here hasn't changed because we put the marble back into the bag, so it doesn't change the total number of marbles for our next pick. And so our next step is we multiply them together. So once again, we write this P for probability, red and green. So it tells us this is choice number 1. This is choice number 2. And what we do, since our operation always is multiply, we multiply these two fractions together. So we multiply our numerators first together. 4 times 3 gives us 12. And then we multiply our denominators together. 7 times 7 is 49. So we could say that the probability of pulling the red marble first, putting it back, and then the green marble, pulling that one out, every 49 times we do this, we're going to pull this probability for the red marble, then the green marble, we're going to pull this 12 times. So now we're going to take a look at example number 2. So very similar to the first example, except there is a little bit of difference that we'll note here. So it says I have a bag of 4 red marbles. So we underline our key parts, and 3 green marbles. So what's the probability that I'll pull a red marble? And then here's the key phrase, that I do not replace it. And then I pull out a green marble. So when we do not replace things, these two events now are dependent on each other. So this is a dependent event. Please label that as so. Now we need to work out the math for this. And so we wrote the letter P for probability. We label the first one in parentheses, probability of red. So this one hasn't changed. So there's 4 red marbles, and 7 is the total number of marbles. So since I'm not replacing the marble, notice what changed here. So our denominator here, 6, this is the total. So this is the total number of marbles left after the first choice. Okay, so we label this probability as green. So there's still 3 green marbles in there, but we now have 6 marbles left. And so to find the probability of these two events happening, we put probabilities P in parentheses. This is choice number 1, choice number 2. So red is our choice number 1, green is choice number 2. And then we multiply these two fractions together. So we have 4/7 times 3/6. So 4 times 3 is 12. 7 times 6 is 42. And then we can simplify this as always. And so what we'll do is we'll do that together as a group. So we know, we know that the probability of this dependent event happening now, for every 42 times now that this event happens, 12 times, we're going to get the probability of having that red and green marble.